Hello, my name is Mads. I'm employed here at the IT services at Roskilde University, and I'm glad to welcome you all to this colloquium called Ruby on Rails to Basecamp. I'm especially glad to welcome today's speaker, David Heinemeier Hansen. We first heard of David when we started using a lightweight project management tool called Basecamp, a web-based tool. We were impressed with the elegance and simplicity of Basecamp, both in form and function. We were delighted to discover that Basecamp was the work of David, a student at Copenhagen Business School, and more, we were thrilled to learn that Basecamp is made with the upcoming scripting language Ruby. And we're glad David had taken the time to come here to Roskilde University to give us this presentation. It will be in two parts. First, 1 hour general introduction, and then a short break, and afterwards David will show us some hands-on programming. And in the end, we will have a refreshment in the hall with beer and soda water, sponsored by Iterator. Please, David.
Thank you. The talk is called Ruby on Rails to Basecamp, but we're going to start at the destination and have a look at Basecamp. Basecamp, as we said, is a web-based project management tool, which is kind of a vague term because this could apply to a number of different systems. What we mean when we say project management is really project collaboration. It isn't a system that's about controlling. It is not a system that's about making Gantt diagrams or other methods of control. It's about collaboration. And what we've chosen to focus on with this collaboration platform is messages, milestones, and to-do lists. We find that the projects we've been involved in, these are the most basic building blocks that you need to collaborate around a project based on some finite scale that has a deadline at some point. And there are a lot of other things you can add to this context and include in a project management system, but these are the basic building blocks. And one of the things that's really important about Basecamp is we stopped there. We just took the most basic we could and made that into a system instead of thinking up new ways and additional features that you could insert into a system like this. The reason we do this is twofold. First of all, because it allowed us to build Basecamp within a pretty reasonable time frame and with a small team, but more importantly because it creates a system that's very easy to use. We've had people look at this system and say, oh, is that really all? Is there all there is to it? And that's deceivingly enough the most important feature of Basecamp. It is that it isn't more than what you see here. It makes the system very easy to use because there's very little to learn. And the things that are included in the systems is components that most people are familiar with. But as I said, when we built this project as a project management tool, different people have different conceptions of what a project management tool should be, which is why we all often get requests that why don't you have time tracking in this system? I need time tracking to control my projects. Or why don't you associate milestones and to-do lists with people? I need to know if my workers are doing what they're supposed to do. And maybe it's because we haven't been really clear about the philosophy behind Basecamp that we get this line of questioning. But we took a stand pretty early on and said, this is not going to be a surveillance application. This is not going to be a management tool. This is going to be a worker tool that's focused around the project and making that a success. So when we say collaboration, it's really about democratizing the whole project, the way the project is run. That this isn't about assigning blame, for instance, which is a common feature of other project management tools. It is I see you haven't met your milestones, so you're not doing your work properly, and you're going to be reprimanded. You don't find that in Basecamp. It's really focused about the communication in the project and getting the project to succeed, and not about assigning blame or controlling. I'm going to show you a few screens from Basecamp just to give you a quick overview of the system. Here's a screen called the dashboard, which is the first screen you see when you're logged in as a firm. This system is built up around the idea that there's a firm and there's a client. This isn't necessarily true for all the projects managed by Basecamp, but that was our outset. So you have the firm that logs into a screen like this, where you get a quick overview of where are we with the different projects we're running. You can see point number 4, you have the list of active projects, which you can click into and then dive into the single project. And then you have the most important screen, which is what's fresh, which gives you an overview of all the things that's happening on all the projects you're associated with. And also here you can see the different elements there is to Basecamp. You see you have the posts, you have the comments, the milestones, and to-do list under what's fresh, and then we've highlighted milestones and made special if something is late. Then you have really the heart of the system, which is the weblog based communication form. This is modeled after weblogs, which is small postings usually sorted with the newest at the top, and you see written it, and there's categories, and you can make your own categories and so on, and then you can attach files and so on to it. And this is the flow where you keep on top of the project. This is, you see the examples here. If somebody posts competitive analysis and there's a picture waiting for an authentication and so on, authorization, where you have normally the firm saying, this is how far we are with the project, can you authorize this change or whatever, and the clients can also post to this. And there's also a comment section, so you can say, no, this picture is not exactly what I wanted, and so on. And in the side you have a little bit more on number 5, the what's fresh within the project itself. Then there's the milestones, which is another important point to it, where first of all you can log the milestones you have upcoming. You can see which are done and which are not done, and late milestones and so on. And you can also get this in your calendar program if you're using iCal or Mozilla. Yeah, and then you have the to-do list, which is also an important representation of the philosophy we've chosen. This is really simple. This is just checklists. There's no magic about, oh, I spend so much time on this, or this is connected to this and this person, which makes the to-do list really flexible. And that's also an important part of keeping this application as simple as possible, that when you have a really simple application, it's much more, it's much easier to use it for different kinds of projects, which is have been at least somewhat of a surprise for us developing Basecamp, because our outset was this is going to be primarily for creative firms that need to present proposals and so on to their clients and have a discussion about that, and that most of the early firm and client setup we looked at was within this industry of creative firms doing just that, which could have been a serious limitation of Basecamp. If we had chosen to make all sorts of specialization directed at making it really easy for these creative firms to manage this situation, which was not of general applicability, we would have limited who could use this project system. Yeah, let's not go to that just yet. Which is a really important point, that we've had a lot of success with Basecamp because people are using it for all sorts of things. We had a guy write in and he's using it to plan his wedding. Yeah, and in our study group, we're using it to plan our bachelor's project. We're using it to plan the communication and organize the communication with an organization we're doing the bachelor's project with. And of course, there's a number of firms in different industries altogether that's using this to manage their projects. And also, even though it's set up with a firm client intention, you don't need to use it as such. You can use it internally in an organization just for internal projects. You don't need to actually have a client to make this work. Our accomplishments with this system. I've talked a bit to Jason Fried, which is my boss in this project. He's from the firm called 37 Signals, which hired me to do this project and that runs Basecamp. And the most he would say about the success so far is it's used by thousands of people to manage thousands of projects, which is, considering Basecamp have been online for 3 months, still pretty impressive, even though I can't say anything more specific about that. But what's also impressive is we didn't went out with a big marketing budget to promote this thing. Actually, I don't think we even spent $1 for the first month and a half getting any publicity on this. All the people who saw this was because Basecamp was mentioned in a whole lot of weblogs. 37 Signals run a weblog called Signal versus Noise, and I run a weblog called Loud Thinking. And we started promoting this tool in these weblogs, and other webloggers we knew got them to talk about it. This created a really interesting circles that just spread out, that you would have one weblogger who appealed to a certain target audience, and they would talk about it, and this target audience again would start talking about it, and it would ripple out. And this, we saw the effect of this pretty quickly. If you searched on Basecamp at Google before this project went online, you found 250,000 hits. 3 days after Basecamp launched, we were at the top of this list because there's just a ton of weblogs pointing to Basecamp. That's of course one thing, getting people to talk about it and saying, oh, this is exciting, because 37 Signals has a pretty good standing in the web design community, so that was pretty easy to get the first round of links from webloggers. But more importantly was when people actually started using the application, this spread out even more, because you see some of the accolades we collected, and people are really, really enthusiastic about this, which is a little bit funny because none of the stuff we're doing is revolutionary in any way. I mean, all of it has been done before. There's been tracking of milestones and to-do lists, and weblogs have been around for years and years. So what is it really that interests people about Basecamp? What we've heard is when people are on a project, they don't really want to stay on top of time here. They don't really want to start another project learning to use some project management tool, which is a lot of these project management tools, if they often want to be very specific and control things, also mean they're very complex, which means that either you just use a small portion of the program to make your Gantt diagrams or whatever, or you think it's just too much and you don't do it at all. And then you come down to the common denominator, which is email, which is what most people making small projects use to manage their projects. And email is a pretty versatile tool, but it's also something where you lock information in the trunk, where if you write something, it's just a communication between you and him, and when you add another person to the project team, they're not going to be part of that conversation. So Basecamp is a lot about taking email online in a place where multiple people can access this, and you can search over time and blah, blah, blah. And we found that a lot of these accolades didn't come from high-tech people that were really into this. This come from normal users, just wasn't intimidated by Basecamp because it apparently did so little, but it did enough to make it really worthwhile.
David, is there a fee for using the software?
Yeah, it's not free. or actually it is free. If you only want to run one project, you can use it for free, and we don't set any limitations on that. Besides, you can't upload files. That's bandwidth issue and so on. We're giving this away. And then there's 3 other plans where you're limited on the number of projects you want to manage simultaneously. So we have packages ranging from $20 to $60 a month, which is also really part of the success. If you want to introduce a new tool to your company, if it costs more than a given amount, you have to get clearance by management, then it never happens. But when something costs $20 a month, you can just pay out of your own pocket, and you'll get the company on board, and it'll be no problem at all. Which is also why we offer all the features that is in the system, even to the lowest paying account. So for $20 you get access to the entire system and 10 projects. Right, so what did we do to make this project? It was actually reinforced by the philosophy we had that we wanted to do something really simple, and also that we knew that if you have too many resources available, you're not going to make anything simple. If you have 5 programmers at your disposal, they're going to have things to do. So it's pretty limited how simple you can make a system if you need to keep 5 programmers busy. So we just had a single developer in the system, which is me, and I didn't even work full-time on this. I I'm finishing my bachelor's degree and had other projects on the side, and the 2 designers from 37 Signals were running a successful web business on the side. And these were not limitations on the system in the sort that it did it bad. These were constraints on the development that really helped fuel the whole philosophy about it, that we needed to keep this simple. Not only did we make a decision early on that we wanted to keep this simple, we simply had to keep it simple because the amount of programming hours we could put into this just limited that there was a ton of stuff we couldn't do, which is interesting because even though you constantly think about, oh, we need to keep it simple, you also constantly think about new features. Oh, it could be really cool if this was linked up and that was linked up and so on. But we just couldn't do that. So yeah, we had constrained time that led to we could only do what needed to be done, and we could only do what needed to be done right now. We couldn't even think, oh, we need to really do this because in the future, we needed to do right now what was the next step. I couldn't plan too far ahead because that just didn't make sense with the resources we had. This created more focus and created the application we have now. Right, and also because this was done as an outsourcing thing, that I'm here in Denmark, I work at another time scale. I'm 8 hours off from Chicago where 37 Signals is based, which means the amount of coordination we had was limited primarily to email and instant messenger and a little bit of voice chat, but which is really low bandwidth collaboration forms. So we couldn't say a lot because it was inconvenient to have huge 2-hour discussions. So we couldn't have these kind of feature meetings where you sit down in a circle and dream up all these kind of features you would like to have in a system. We just had to communicate on what needed to be done. Right, and because we were then so few people, it very quickly created a culture where we needed to say very little to mean very much. And as such, we didn't need to write a huge specification for this system because we had a very good feeling of what we wanted to do, and the philosophy was adopted across the entire team. Yeah, I want to jump to something else, which is when we first presented how we did this online, I wrote about it on my weblog and said, use this 2-man month quote, which got a lot of interesting reactions. Either people thought that we must have done a huge amount of homework, like a film project where you spend years in pre-production and then shoot it in just 5 weeks. Either we did that, that is, we followed a really rigorous approach, and that was the only way we could set ourselves up for success, or we did the thing, the totally opposite thing, which is just hack this thing together as quickly as we could with Scotch tape, and it was gonna fall apart 2 weeks after we launched. Well, we did neither of these things, but it's interesting to see the assumptions that goes with each of these dismissals, where, especially in the quick scenario, when we say we did this really quick, it kind of goes together with another word, which is dirty. So if you do something quick, you do it quick and dirty. And that's the normal association you would get. But our interpretation of why we did this is, yeah, as we talked about a little bit, we just made less software. We just made less features, and the features we had, we didn't spend that much time on compared to what we could. And we were, for a lot of these philosophy things, we were inspired by the agile software development movement, and in particular extreme programming, which has a number of slogans on how to do things. And we see this as making less software is the strategic proposition to the tactical, you're not going to need it, which says when you're actually coding these things, don't code features that you don't need right now, but perhaps will need tomorrow, and so on. And do the simplest thing that could possibly work. Or often rephrased, do slightly less than the simplest thing that could possibly work, because you always think you need to do more than you actually do. And then the cross-professional, just need to keep track of time here, interventions was that we didn't have a clear border, which is actually something, it seems, extreme programming advocate, that the customer has a set of obligations and the programmer has a set of obligations, and each know their domain. So the programmer can't say anything about the business domain, and the business person can't say anything about the development. Well, we didn't find that to work very well. We found that I could have a programming problem where I couldn't find the simplest way, and I could ask Jason about that, and he didn't know much about programming. He had done a few PHP scripts, so he had a whole nother view at it and just proposed something even simpler, and was like, oh, yeah, of course, do that instead. And the same with the design, that they sometimes dream up something which would take a lot of work for me to do, and I propose a simplification to that, which leads to an even better UI. But anyway, the point is that it's actually better to mix this and not have clear borders between the obligations on the two parts, which is something that, I don't want to go too much into that. The other thing was be fanatic about productivity, which is really why I'm presenting this, because there's some technology behind all of these principles as well, which is the Rails framework. That it was just me programming, so I had to do everything I possibly could to make the most of each hour I put into the system. I couldn't spend 5 hours of something and then not have something to show, which means that you have to have a pretty high productivity to allow that to happen. Which leads us to Rails. Rails is the name of this web framework we developed while building Basecamp, and Basecamp, of course, is built upon. And we built this alongside building Basecamp, which is another really, really important thing about building web frameworks, is that you can't do it in isolation. You can't do it outside of a real project, because if you start doing that, it'll be a web framework that's really optimized for your simple tutorial-like examples. And they do those really well. But then when the graphic designers, which is in my case Jason, overseas come and say, oh, I need to have an explanation right here next to this form element, because that will work really well for the user. And you say, oh, I'm sorry, my web framework really isn't built to that. So that's a really important feature, and why I spend so much time talking about Basecamp, since this is mostly a technical presentation, is it influenced it enormously. And Rails wouldn't have been anyway what it is today if it wasn't built alongside a real project like Basecamp. Rails is built on a pretty common pattern for separating different parts of the web application called model-view control. You have a person sitting in a browser making a request like, show me this post. This request goes to the controller, which is the octopusy binding the whole system together, which then goes down to a database and a model and says, oh, I need post number 25 because I got that request parameter, pulls it out of the database, initialize an object, takes this object, gives it to a view. The view is then responsible for presenting post number 25 to the user. And then this cycle goes around again. The user will choose to edit this post, delete it, or whatever. Why do you make this split? If you're used to this kind of development, it's a pretty easy answer, because if you make any application of model or mild in complexity, it just gets too much if you mash all of these 3 layers into one, which is often what you associate actually with scripting languages like PHP. It is just one script doing everything. Well, we split these out into 3 parts because it's just much easier to keep an overview of the system, and you can test each of them in isolation and all sorts of good things. Right, the Rails control, which is the first thing, or where the request goes, for starters, is you perform something which usually is a CRUD, create, read, update, or delete a given model object. And model objects are the things in the system that you're trying to model, which is, for Basecamp's example, things like posts, comments, authors, projects, and so on. And then the control either chooses to render this model object that it found, or chooses to pass this control to something else. For example, if we have a delete request, say, delete this post number 25, it deletes the post number 25s, and then redirects to another action, like the list of posts, with a little note saying, I deleted number 25. Right, and then we jumped into something slightly more technical. This is a dump of actual code from Basecamp. And what's interesting about this is mostly what's not there. There's a single controller handling multiple actions on login. For example, you have the index, which is a show method, which will, unless the account is not active, then it will just render the login screen, the screen where you input your username and your password. Or if the account is inactive, it'll render a screen saying you can't log into the system because it's inactive. And this is also, as you see, this is Ruby code. And the reason I didn't spend too much time introducing Ruby beforehand is, if you've programmed in pretty much any language before, this is pretty readable code. And it's actually more impressive if you haven't been introduced to the language, that you can just pretty much read it. Then we have the authentication method, which is really the workhorse of the login controller, which will assign a person to the person variable if he authenticates. If he doesn't authenticate, we set an alert, username password invalid, redirects back to the index. And here you can see, if you go through the authenticate, that it has, well, this actually has 2 outcomes. Either you're successful and you go to your client, it performs the client login method or the firm login method, otherwise you go back. And then the index screen will again give you something to view. So the index is the first part of it. This will view something, and the authenticate will do something and then pass control to somewhere else. It's not really important that you understand the code here, just wanted to show you something real from Rails and look at Ruby. Right. Since the control is really just the boss telling people what to do, telling the model that I need a post, telling the view that you should show this post, it's not really where most of the application is situated. You have most of the application in the model, which is this abstract vision of the things, as we talked about just before, that is of concern to this application. Here's some examples of model objects or business objects from Basecamp, projects and the use and the milestone and so on. The important thing about having a separate model in Rails is that you bind data and logic together. So you have a totally separate model that could actually work in a different setting than a web setting, for example. It could be a GUI application. This is not what Rails is about, though. This is about creating web applications, but it's pretty important to understand that the model is self-contained. We don't split information about how the model works and the integrity in the model out to something else. A lot of either simple scripts like a PHP script that just pulls something from the database and then displays it will not have a separate model that's self-contained. It would just have some data in the database, so you have the name of the project and a description of the project. That's just data. And then you pull that out and then you do something mashed together with the view and so on. Whereas in the model, you keep all the things that pertains to the module, all the logic in these module objects as well. That's a bit abstract. So an example of the logic that's kept in these business objects is a project needs to know if it's active enough. If you remember the list we had on one of the first screens, we have a list of active projects and we have a list of inactive projects. That's not a simple flag. That's a calculation you need to make where you look at how recent was a post made to this project, when was it last accessed, and a lot of computational things that you can't keep just in a flag. That's the logic. We could put this logic down with the data, and this is obviously what object-oriented programming is all about, but often something that is just not used if you move the object-oriented system online. That you start mixing these things together, and all of a sudden you just have a model that's only data, and then you spread your logic thin over views and controllers and so on. Right. The thing about having the logic there, that's important as well, but that's pertain to normally individual model objects. So the project will know if it's active or not, but there's also the relationship between the model objects that's important. At the bottom, as I post has many comments and belongs to an author. That's a statement you say about the domain, and we really, with Rails, wanted to represent that in the model as well. Whereas, again, oftentimes you split that out, so it's the controller that knows how posts and comments are associated. So it will get one post, and then it will look at the post ID, and it will use this post ID to get some comments. No. We need to keep this together in the model, because when we do that, we can test the model totally independently of the rest of the system, which is another pretty important focus for Rails, was that each of the different layers needed to be testable in isolation, because it's just so much easier to test something if there's less code to test. When you test something from a black box perspective, where you just sit around and click in the browser, if something goes wrong, where is it exactly in these 4,000 lines of code that things go wrong? Whereas when you have this isolated model, it's just way less code to test. And right, here we have two examples, or one whole example and one half example of model code. The first is a file attachment, which is a subclass of an attachment. And you see, the first is to represent the association that is in the model. This file attachment belongs to a person. That's the person who uploaded the file. And it belongs to a project. That's the project you upload the file to. Then it also has a number of logic methods. What you don't see here is the missing part. Where are all the attributes? Where do you see what the name of it is and the URL for this uploaded file and so on? And the answer is you don't. Since Rails is built to be run with a relational database, you need to have all that information, you need to have that somewhere else as well. And there's actually, that's where you need to have it. That's in the database. The database needs to know if a project has a name and a description and so on, because you do that in your definition tables. Another place people often repeat that information is in the model, because they want an object-oriented facade to this database, and then they replicate this. This is also goes a bit to the pattern chosen for this implementation. The model part of Rails is implemented with something called an active record, which is a pretty tight connection between a single database row and a single object. So if you get project number 30, it will go into the database, look at row number 30, and pull that information out and present it as an object decorated with these logic methods. So normally you would present these two places, but Rails says there's only one place you need to have it, and that is in the database. So why don't we just have this code present this automatically for you? So when you initialize file attachment, it will automatically have all the attributes that the database representation of it has. We will return to why this is really important, but I should go on to some of the rest of this model stuff. The post, for example, here I show how some of the associations in the model isn't necessarily as easy as belongs to project. Because belongs to project is a pretty simple association, because we have a thing called post and we have an object called project. It's pretty easy to calculate the rest of that. Whereas when you have something as has many subscribers, subscribers is actually not, or subscriber is actually not a model object in itself. It's a role that another model object will take upon itself. In this case, person. A person will appear as a subscriber in relation to this post. This goes to in Basecamp that you can subscribe to a given post and then you receive an email notification when new comments come in and so on. This is just to show that not all of the parts of Rails look as pretty as belongs to project, because well, reality in this case, Basecamp isn't as simple as that. You can't represent everything as neat and tidy as that. And that's really one of the major realizations that we had with Rails. A lot of other web application frameworks will try to say, for example, as you see here, this is straight SQL code. This is bad. You want to keep that out of your application, and you only want to present something unified as a completely object-oriented approach, which leads to totally ridiculous things like rebuilding SQL in object-oriented programming lingo, because, well, actually we needed this stuff. We needed to be able to get these subscribers, but we didn't like SQL, so we just had to build a replacement for that. I don't think I'll go into that, but I attended a presentation not too long ago on a Java-based framework, which was pretty funny, because this guy was a lot of the same ideas he was using, and then just had the idea that we needed to keep this object-oriented world of ours pure. So he didn't like SQL and banned that from the project. So instead of having like the 3 lines you have there, which is basically 3 lines just for clarity, he had a method, I think, that was like 8 or 10 lines long with really, really complex code that did the same as SQL, because that he needed that, but just didn't like SQL. And then he just pointed at, isn't this beautiful? Because he had wrapped SQL somehow in object-oriented, and that was supposed to be a big thing. You don't really get to have these excursions when you do a real job on the side. I didn't have time to reinvent SQL, and there wasn't really any need to reinvent SQL, so why don't we just use SQL? Right. Then we come to to the view, which is where we actually present any of this stuff. This is all what the user sees. They also got the presentation layer, and all the screens you saw before were renders of templates made in this view. And the reason why you have this view is that you have a really simple front that you could change easily, and that doesn't contain a whole lot of logic, so you can give this view part to a graphical designer, for example, and he can mark up some HTML, and you can just sprinkle a few tags across it, and it'll work, because you already tested the rest of the application in your control and your model, and you already have all that stuff, so you have the whole thing working, and you're just putting on a face to it. Right, and here's a few chunks of that's not very readable, of Rails view. The first one is presenting a form for a message. So you have the title, and you have the category and body and so on. And then I've sprinkled some tags around. The green stuff is where the view code come in. And the view code in this in Rails is just plain Ruby, which is another diversion from the common pattern, which is to build a separate template language, because that's supposed to be really easy for graphical designers if we build another specialized language just for them. And it turns out that it never works that way, and these template languages always miss something, because most of them were created just with these toy examples. Look how pretty it is, and then when you actually need to use it for something, it's really complex. Anyway, right. The part about having, yeah.
I'm afraid I might be lost. Is this HTML or?
This is it. Yeah. I didn't make that clear. All the view part in Rails is just plain HTML, and then decorated with Ruby tags where we need to have something dynamic involved. And you can see the blue methods, text field, select from collection, text area. These are the example of Rails wanting to pull logic out of the view and into specialized methods for it. So what text field does, it says text field for the object post and the attribute title. So we'll make an input field, an input text field for the attribute title on post. Why do we make this and not just make it in HTML? This goes back to the productivity thing. When you write this out in HTML, you have a lot of repetitions. You repeat the name of the object 3 times. I think you need one in the ID of it, you need one in the name of it, and so on. And also when you do it like this, it'll be pre-filled. Now it says new form. If it was an edit form, we could just use the same form and give a post object to it, and it would render the contents of the post. That's the most common thing to do. That is just to take a model object and then display it in some form of HTML. Then you also have a little bit more complex logic in the bottom one, where you have an iterator that post comments, as you see here, which is also interesting. This is the post, the app before the post means that this object was assigned to the view from a controller. So we have post, that's what the controller gives to the view, and then the view can access all the parts of post itself. For example, post, if you access the method comments, will give you all of the comments in this for a loop one by one. So first we show the post at the top, and then we iterate down and show all the comments to it. But as you see, it's also sometimes sprinkled with a little bit of logic. For example, the H3 tag, which is used for the title of the comment, is highlighted if I'm the author of that comment. So my comments stand out when I see it. And that's just, you have a little bit of if person full name equals comment author full name. This is actually using just a little bit of logic in the view to make something that could otherwise be a little bit complex if I needed to have that into my model, for example. That perhaps wouldn't make sense. This is something about presenting the comments, and that I wanted to highlight with some of this. So this really pertains to the view. which is something you run into when you actually start using these views, is that sometimes, like this, you just need to have logic in there, and it's not necessarily a bad thing because the alternative would be way much more complex. So Rails tries to look like the top thing most of the time and just present stuff, and then when you actually need a little bit of logic, you can do it. Right. Okay, I need to speed up a bit. I talked about the view, the model, and the controller just as being parts of Rails, but actually they're independent projects which are just swooped together into Rails. The first one called Action Pack, which is a name for two projects, Action View and Action Controller. They pretty much say what they are. There's the view part and the controller part, and then there's the active record, which is the name of the pattern I implemented for the model part. Right, this is a little bit more technical look at how the request flow works. So you have the browser that requests a URL like that, like blog display 5. And as you see, that's actually how the URL looks, which is another feature of Rails, is that you have pretty URLs from the get-go. A lot of other web applications will have huge strings to represent this, and ugly, hard to bookmark, blah, blah, blah. But Rails uses Apache for most of it for all of the serving of web content. So it's natural just to use the Apache project called mod rewrite to make these pretty URLs. You can see the transformation that the browser requests the pretty URLs. Mod rewrite rewrites this URL to dispatcher, RB, and pulls out the blog. That's the controller. And the display, that's the name of the action method. And then the ID on the end. And then it calls the dispatcher. The dispatcher is just a little front box sitting on top of Rails, telling Rails what to do. So it'll initialize Rails, which is configured framework. It'll wrap this CGI object into a request and pass it down to the action controller. So this is also pretty important, that the action controller is not tied to CGI, which means that when we don't want to run CGI, which is in a test setting, we can just give it a test request and test it like that. Anyway, creates the action controller. The action controller then determines, the action controller initialized will be block controller. You see the name of the controller is block, initialize block controller, and then we'll call the method display, because that's the name of the action. And this display will then get an active record, which is probably a posting for the block. That's ID number 5, so it'll say, give me post number 5, and then it'll render an action view, which is like the one we saw before, that's used to show this posting, actually send it back to the browser, and the loop continues. Right. We have 5 minutes left, and I have too many slides. Okay, quick overview of the features in Action Controller. Action Controller is what most people think of actually when they think of a web framework, which is something like Java. They have struts and Xwork and all of these other projects which does the same thing as Action Controller does in Rails, which is actually something I didn't focus too much on, is that Rails is a web framework for the entire web application, whereas most web frameworks choose one out of the 3 parts. Either they'll work on the controller, which is what struts and Xwork does, or they'll work on the model part, which is what, again, Java reference Hibernate does, or they'll work on the view part, which is something like Velocity does. So when in Java you need to build something similar to this, you need to pull together normally at least 3 projects, and then all the glue in between, which is also a pretty important feature of Rails, is when you get the blank box, which is Rails, and start using it, you have all the components that you need to build a complete web application. Anyway, as we talked about before, the main purpose of the action controller is either to render something, which is to give a model object to a view, or to redirect, which is either to another web application entirely or to an action within the same controller or to another controller. It's called action controller because it packs more than one action into a single controller. Yeah, that makes sense. Whereas the normal way of doing it, or the patterns recognized for doing this, is something either called front controller or something called page controller. Front controller is you have one box setting up guarding the entire application, and then when a request comes down, you serialize this as a command, and each action will be an object in itself. And so you have the request coming in, then you have a front controller, which is a little bit like what rewrite and dispatcher is doing here. And then for every single thing, like edit form or create post or something, you have a whole object, a command object. And these command objects are not 2 lines of code. For each object, you need to set up everything again. So that's normally a good page worth of code to have each of these. Or the other case you have is you have a page controller, which is similar to this, just where each request goes directly to this command object. This creates a ton of objects and a lot of boilerplate code to create just a single new thing. In Rails, we bundle these together. So, for example, that's the other disadvantage with having a front controller. You don't necessarily know how to bundle these things together. You just, everything is equal. So something to do with post is here, and something to do with milestones is here, and so on. Whereas with action controller, we'll package these into things that goes together. So for example, we'll make a milestone controller, which has something like delay milestone, create new milestone, and so on. And we'll say these 3 commands, they all talk about the milestone. So we'll make one controller, which is called the milestone controller, which can, besides having each of these 3 actions, can also have some shared code, which is important to the milestone. Right, in the boxes here, I have 2 examples of these actions. Like the first one, display. That's a whole action in just 1 line of code. The only reason why it's 2 lines of code is the box is small. So normally you would have a really big command object called display customer, which would be a page of Java code to do what Rails does in 1 line of code. Right, another feature of this is something called filters, which is a way of pulling out what we call cross-cutting concerns, which is things that pertain to multiple action controllers, like authentication. Both the milestone controller and the post controller needs to know if this person is logged in or not. So we can pull this code out of each of these controllers and centralize it someplace. We don't have time to go too much into that, so let's just skip on to the active record, which is the model part, which does basically these 4 things. The mapping, which is when there's a title and a body to a post in the database, you can interact with this post object in an object-oriented fashion in your code. So it presents each row as an object. And you will do these things on create, read, update, destroy. And there's a small example here where you see I initialize a new person. That will be an empty row I'm ready to insert something into. And when I save it for the first time, it'll generate this insert SQL statement and do the things. The association, we had a look at those before. That's the has many post, belongs to, author, and so on. Right. And then there's the validation, which is also something Rails does differently than most web application frameworks that keep validations on the front end. So they validate all the stuff that goes into the model, either in the view with some JavaScript on the controller. Again, but the disadvantage of doing it like that is that you actually need to repeat these things. If these validations, for example, if account can't hold more than $1,000, if that's a restriction in your model, you shouldn't place this at the edge of the application. This is something that you need on the model in order to consider it whole as an integrated unit that you can test and so on. And normally people realize this and just do it at both ends. So they have the same validation on the front end as they'll have on the back end. Then there's something called callbacks, which is a way of implementing an observer pattern if you have if you want triggers, something like triggers in a database, just on the object code itself.
Hey, David, just a question. You have to explain the person.name. It looks like a normal attribute.
Right. That's the thing. When I initialize this person new, let's say there's no attributes. I want a whole new person. It'll go down to the database, look at the columns in the database, and says, oh, this table person or people have name, address, and so on. It'll then take these column names and make accesses on the person objects for them. So you say person.name equals David. The reason you can do that is because this active record knows that there's a column called name. If there wasn't a column called name, you would get this is not a method, blah, blah, blah. So this is a way of wrapping the creation of new rows into a object-oriented fashion. Did that answer your question? Yeah. Right. And then there's the action view, which is the view part of Rails, which uses normal, regular Ruby, which is something that is normally railed against, that you use a real programming language for the presentation layer, because all doom will come. People say that you will shove all your code into this presentation layer and you will not have integrity in your model anymore, because people will take stuff that belongs in the model and put it into the view. Well, I got thinking, why does this happen? This normally happens because it's way easier to program in the view than it is to program in the model. So people will go away from the model, because that's all this heavy Java code where I need to do 3 layers of mapping and toy around with XML files and blah, blah, blah. Whereas in the view, which is normally a separate scripting-like language, it's really easy. So the reason people does a lot of stuff that doesn't belong in the view is because it's easy to do in the view. Well, guess what? The view is just Ruby, like Ruby is in the model and like Ruby is in the controller. So there's no inherent advantage of shoving all your logic into your view, which is why I'm not really that afraid of people just putting a ton of stuff into the view that doesn't belong there, because it's not any easier. Actually, it's a little bit more complicated because you have to mix it in with the HTML and so on. Anyway, the way it works is, there's the helpers, which is what pulls logic out of these views and into helper objects. There's like a form helper. This is the stuff for text field and password field and so on. And then there's a couple of text helpers, which is for truncating text when you need to present, for example, an excerpt of a post. You just give me the first 100 characters and then ... This is not code you want in the model because it pertains to the view. And it's very easy to make more of these helpers yourself. Right, which brings us, we've touched upon this already, but a little bit to the Rails philosophy, which is conventions over configurations. Rails have one configuration file you need to set up when you start the system, which is what's the name of the database, what's the user for the database, and what's the password. This is all. Whereas most web frameworks at least have this major mapping, often called web XML or something like that, that needs to map every request coming in to a different controller and what it needs to call on the action and so on, which leads to, for example, 3 configuration files in XML you need to change every time you add something, which is a huge overhead that leads to you don't want to make changes. You rather want to shoehorn more or burden existing objects more because it's just too complicated to make something new. Whereas here it is all this mapping stuff that you normally use to do explicitly happens automatically. And this also leads to conformity. If you do it like Rails really wants you to do it, you get a ton of stuff for free, like all this free mapping and so on. And it leads you to follow a number of naming conventions and a number of conventions of structuring your code, which hopefully leads to two Rails applications will feel pretty much the same in their structure, because if you do it the Rails way, it's easy, and if you don't do it the Rails way, it's just like doing normal code. But once you've tried that, hopefully you'll just follow that. That's also something about best practices that I try to force upon people. So when you create a new model object, there's a convenient generator for you that will create a number of small files for you, so you just need to go in and edit. But if you use this generator, it will also create a unit test file for you. And more importantly, it will have one unit test in it that fails, that says this hasn't been implemented yet. So when you run your build process for the first time, you'll get a number of failing unit tests saying, oh, you should really implement this. And maybe you felt like you were in a hurry and didn't really have time to do the unit testing, but when you keep getting reminded of this fact that, hey, dude, you didn't test, then hopefully it will lead to people start testing. And that's also something about an established helper structure, so you don't get these views with a ton of logic in them. Right. Leaves us very little time to explain about Ruby, but just a quick overview.
After the break?
Yeah, we can do that as well.
Okay.
Yeah. Right, and this also leaves very little time for that one. What? Even less time, it seems. Right. Yeah, any questions, or do you want to skip to the break right away?
Remember to repeat the question.
Right. Any questions? Damn, I'm a good presenter then.
Why do you want to keep the controllers out of the model? Don't they belong naturally with an object? Like it's an action with some objects.
Right. The problem is that the controller knows everything. The controller knows the names of the views, and it knows the CGI object coming in, and there's request parameters and so on. If you shove all of that knowledge into the model, you get a model that knows everything about everything, which is really getting back to just having one page of code. You want to separate these things so the model doesn't know anything about how it's presented, because then you can test it in isolation, and you only have methods on the model objects that have something to do with the model. Right. Anything else? Yeah?
The relational object bridge you've built, how much help does Ruby give in implementing that?
Right, that's actually the right, I need to repeat the question. How much help does Ruby give to this object relational mapping bridge that I built, the one called Active Record? This is actually the point in Rails where Ruby have done the most benefit. The slides I skipped over would talk a lot about how Ruby is extremely dynamic, so you can reflect all of the objects you have in Ruby. You can get all sorts of information about them. What methods are they taking? What are the parameters and so on? And just as importantly is that once you have this knowledge, you can act on it. You can extend all of your objects at runtime. You can add new methods to it. For example, the person object we had before you talked about. This person object is extended at runtime with a name method, because it'll look into the column, see there's a name column, and then add a method to the person that is called name, which is only something you can do when you have this extreme degree of introspection, so you can reflect on it, and on runtime extension. I actually did this, or a version of this framework, once before in PHP. PHP doesn't have any of these features, which means that you have to have build phases. So you create a markup language or meta language for describing these things, and then you run a script on it that'll generate some PHP file in some real files, and then you run that, which is, besides adding another phase to every time you need to do something, which is really inconvenient, it's very limiting. You have to have two representations of the same thing. That is also how you would do it in Java or most static languages. You would have a pre-processor running through some things you do. Whereas Ruby have all of this in the language itself. Yes. Right. Okay, I think that's it then.
We take a 5-minute break and meet here at 16 minutes past.
Right, and for the next session, you want to be at least somewhat interested in actual code stuff, because we're going to sit and code a little application in Rails. So, yeah, just if that doesn't interest you, you shouldn't come back. 5 points to describe why Ruby is especially well suited for web application development and for being the language in which Rails is constructed. First of all, this is a very uniform language. I come from a background in PHP where it's just everybody who had an idea of some function that would be nice to have in a language threw it in there. And there's little to no consistency in how it's done. Ruby is pretty much the exact opposite on that point. There is very much consistent in how everything is done, which all springs from the object-oriented base that everything in Ruby is an object. So you have numbers and strings and everything is an object instead of having this where some base types are considered not objects like you have in Java, and you have boxing back and forth and all the problems with that. 5 times do print hello capitalized N will print hello world in the capitalized versions 5 times on the screen. And that's actually exactly how the code looks. And that's the other thing about when everything is an object like this and everything is very consistent, it gives code that's very easy to read. That a lot of Ruby statements you can read out loud and they actually make sense. And then there's another really important thing, which is the blocks. The blocks is something where I'm not sure how actually to describe it, but I can read this code aloud and then explain what it does, and then you can see. We start with a DB variable, which will hold our database handle. Then we select all, some SQL statement, which will return a number of rows in an array. And then we inject another array, which we're going to use to collect the object versions of all of these rows. The rows are just the data. That's just the name and title and so on. And the objects are fully instantiated versions of something like file attachment, as we saw before. When we run inject, it'll loop over whatever was given to inject. This is what's coming from select all, that's an array. So it'll loop over the array one by one, giving the row, and eject, that's then the objects. So we instantiate the row. That's a method I have for taking the row and looking at it and turning it into an active record object. And then we add it, we do that with the 2 arrows, to the objects array. And all of this returns, this is inject, is the last method we're running, will return the array we injected. It sounds a little bit confusing, but it's really not, and it gives that this code you have up here had something similar in PHP, which was just a ton of code because you couldn't string all of these methods along just out of one line, and have stuff like inject where you loop over an array as an iterator and then collect the results of what you want. And that's something that is really apparent when you look at some source files for Rails, is that you use these blocks all the time. even though they perhaps are somewhat hard to explain if you're not used to programming in a language that has something like this. Then, as we talked about, there's a lot of reflection, really an amazing amount of reflection. When I started doing Rails, I came from PHP and doing the same in PHP, and PHP has just a small handful of functions for doing this reflection. And Mats, the programmer of Ruby, really have added an amazing amount of reflection methods to Ruby that sometimes when you look at the list of things you can do, you ask, why would I ever want to know that about an object? But it turns out when you create a framework like Rails, you very often want to know a lot of details about how a given object was implemented. And it makes it so much easier to create a lot of this magic stuff that's going on, where it just looks like you code 3 lines of code and then all sorts of stuff happen. Then of course also the extension at runtime. You can extend any object in Ruby, like the number 5, for example. If we want to add a method to that, we can just add a method to the class fixNum, and all integers in our system will now have this method. You think, oh, isn't that pretty dangerous that anybody can extend anything in the system and that's gonna blow up pretty quickly? Well, it turns out that it doesn't if you just follow a couple of pretty simple and pretty straightforward conventions. First of all, even though you can override existing methods on any object, you really don't want to. I mean, if I override times, which is a native object of fixNum, I would know that anybody who otherwise used fixNums in my system wouldn't expect that behavior. So that would of course be stupid. But if I add a method called truncate to the string object, nobody's going to expect that string can do truncate and then use it the wrong way. That's just a method I can add for my convenience to the base classes. And I don't do that a lot. You don't really add a lot of methods runtime to the base library. But sometimes it's really needed. For example, the CGI library in Ruby is not really that good. It's mashed in with a lot of stuff, like it has something for building HTML tags, and it's really mashed together, so it does a lot of things, which is, it does a lot of things, and most of the things it does somewhat shaky. Which meant that I had a method in PHP where you could form tags if you named them accordingly with brackets. So if you had person bracket name and then you had person bracket address, you could extract just one array called person that would have both a name and an address as one thing, which is really, really convenient and used a lot of places in Rails. And it didn't have that in the base library. Now, either it could add something, I could just create my own CGI version, or I can just take all the work that was actually in CGI and then just patch the little pieces that I needed to patch in order to make what I wanted work. And that turned out to be the perfect solution for Rails, at least, because it was just so much easier. And it goes like that a lot in Rails, or in Ruby, that you can just add a little bit to something existing and then get what you want. You don't have this situation where the author of some library went away and all you have is whatever he intended just right now, which is also something in the XML library I used a couple of times, just added a few convenience versions and made everything easier for me. But it is of course something to be treated somewhat with respect, that you don't just litter new functions all over the class library and expect all to be well. But people don't do that, which is a funny debate about Ruby, is that a lot of these things that Ruby has is so powerful that a lot of people say, oh, that is just way too much. People will screw up and that's enough rope to hang a whole team of programmers. But it turns out that, at least my experience, that just doesn't happen. You use these features with sensibility, and then you have a really, really powerful system that these few dangerous things that a language allows you, you just use that in the 1% of the incidences where it really, really matters, and then otherwise treated with respect. Then the other thing that's often lamented against Ruby is that, what about the standard library? When I jumped from PHP to Ruby, that was something I feared, that now I'd had to build all sorts of libraries because Ruby is a young language. Oh, young, it's from 93 or something, but it has the sense of that, and with that comes that there's not going to be a lot of libraries. Well, it turns out there were more libraries in Ruby, and they were of better quality than what I experienced in PHP, even though PHP has a ton of libraries for all sorts of weird things, and oftentimes they're totally inconsistent with how the rest of the language is implemented, because it seems like less so in PHP, there's just a common way of doing things, whereas all the libraries or all of them I use most of the time at least, in Ruby has a sense that there's got to be one guy doing this, right? Because this is just a way of consistency to these libraries that makes it so easy to learn Ruby and so easy to use Ruby. But it doesn't come from just having one program. It comes from a language that was founded on consistency, which makes it pretty easy to guess how you should do things. Right. Yeah, another thing, three nice things about Ruby. One is the interactive Ruby, which is you can drop into a console, play around with the language interactively. This sounds nice as a way of learning the language at first, but it's also a really, really nice thing when you're actually coding, because oftentimes you have just a few methods you want to try out. How do they actually work, and how can I fit them into my program? If you want to try that out and not have any interactive mode, you have to actually make the changes to a program, which is something perhaps you're not sure of these changes, and you have to run your entire program just to test out how 5 times something works, or if that iterator takes a parameter like that, and if this really works like that. Whereas in Ruby, you can just, I could show that a little later, drop into the interactive mode and play around. And then there's an exceedingly friendly community focused around a mailing list called Ruby Talk, which is, I think, a lot to do with the adoption of Ruby still being so small that most of the people using Ruby are either pretty smart academic types that are interested in the language because it's pushing something, or just programmers in general that think more about how can I increase my productivity and how can I do more with the language, which leads to there's a smaller number of people. Ruby doesn't attract tons of newbies, which is actually what something said about PHP, where I come from before, that it's like 3 million PHP programmers. Well, so what? I mean, most of the time, first of all, you just need a couple of programmers, and the other thing is that it pollutes like the repositories of code. If you look at any of the project collections for PHP code, it's just 1 in 100 that's going to be a hit, and the 99 out of it is just going to be crap code that somebody just learning programming and all did, and that's all fine and well, but it just decreases the quality of the stuff that's available. And just as importantly, how easy is it to get hand of the experts? It's really easy in Ruby. Most of the experts that did the used class libraries and such hang out on Ruby Talk. So if you have a problem with how the unit testing framework is implemented, you just ask on Ruby Talk, and the guy who did the unit testing framework will answer. Or if you have a problem with the language, you write out, and the guy who did the language will answer. Mats, that's the Japanese guy that did Ruby, hangs out on Ruby Talk and answers a bunch of questions all the time. This leads in total to a really friendly community that makes it just so much more fun to be part of. And it also feels like there is a core community, whereas if a language is widely popular, there's going to be a ton of segments. And this is from Mads. I attended a speak by him, the programmer of Ruby, last year at JAO, where he said one of the reasons he did Ruby like he did was he wanted developers to have fun. That's a pretty interesting concept. Most of the time you say, oh, a programming language is a tool and I'm supposed to be doing really rational things with this, and this isn't about having fun. Well, in Ruby, a lot of the time it is about having fun. And that's funny coming from the creator of the language, and it really inspires a different community around it, which is great to be a part of. Anyway, right.
So I do have a few questions before I start.
Yeah.
Could you tell us a little bit of the process which led you to choose Ruby for the Basecamp project?
Right. Repeating the question. So, what process led me to choose Ruby for Basecamp? Well, that's actually a little bit funny because all the other projects I've done with 37 Signals were done in PHP, and 37 Signals were comfortable that we used PHP and so on. And at the same time, I was building something similar to Rails in PHP. And I was just constantly running into limitations in PHP that were really frustrating and led to a lot of, I felt, just bad code. So I actually had the recommendation of Ruby a few times before, and I actually even attempted to get into Ruby once before I actually did it. But it just, for some reason, it just didn't catch on. And then when I was really frustrated about PHP, I just started looking at other languages. So I thought, this is just too much. I'll look at some Objective-C and become a GUI programmer instead, because this is too much. And then that turned out to be not exactly what I wanted anyway. And then I got, hey, let's give Ruby another look. And then when I did, apparently I was just more ready for it. Because one of the things that is about Ruby is when you get into the language, unless you have a pretty good guide along, it's really hard to find where is the good documentation on this. There's no the same kind of like Sun pushing Java. You go to the Sun side and then you get all the reference documentation and tons of tutorials and so on. It's just more spread out in Ruby, and you have to, there's this initial barrier that you just have to climb in order to get on with the language, which is, I mean, I've come to appreciate that a little bit afterwards, because that's also what keeps out all of the people who didn't want to climb that hill, which is actually leads to an interesting situation. That's what you want in some cases, that it's pretty nice that you don't have a ton of people using this language because great quality, blah, blah, blah. And then it's just a point of, okay, this looks very much like I wanted, and I spent 1 week evaluating the language and building a skeleton version of Rails in just that 1 week. And I thought, whoa, it took me, I don't know how long to build the same in PHP. And when I looked at the number of lines of code I needed to do this, it was like, this is too good to be true. So I didn't recommend Ruby at first, and then spent some more time with it and found out, at least for our purposes, it did seem to be too good to be true, and it was. And then there's also always this battle when you want to convince management that you want to use not a mainstream language. But luckily I work with a company like 37 Signals, which is just a few guys themselves, and I had built some authority, so I said, this is what I want to do. We're going to build Basecamp in Ruby. I was like, argh. And then, of course, it didn't take very long. Once we had the first few features up and they saw that it was working out, it was just, way, Ruby is the best. And now 37 Signals are pretty enthusiastic about this as well. And we say, oh yeah, Ruby, way. And that's pretty cool. And that's really the way I think in general you should introduce people to this. Don't talk about it like this, because at least these people in 37 Signals weren't really enthused. But in Ruby, everything is an object, man. I can call times on 5. How cool is that? It's like, I don't care. Once I started delivering something to them that was of use, and I did it quickly, it was like, that's what impressed people. So instead of saying that you want to use Ruby, just use Ruby and show them something cool in it. That at least worked for me. Right. Any more Yeah, there's a couple of things to that. The first thing being that we really didn't care about performance early on because the kind of application that Basecamp is you have a very small amount of people, because most of the people using Basecamp are the people paying to use Basecamp. So when we get a new account, say somebody pays $40 a month to have this, they will then have 10 users or 15 users use this. So it really doesn't matter how bad it performs. I think it performs very well, and especially if you create an object-oriented system, which is what I tried to do in PHP, and that performed pretty shadily sometimes because PHP really don't want you to use the object-oriented features, at least in 4. I hear it's getting better in 5, but so there's the first hit that starting up, for example, Ruby is a bit slower, but that can be offset by a number of projects. Like we use something called ModRuby, which will instance one interpreter and then reuse that, so you don't have to hit every time. But I mean, that's actually the normal way of doing things. But it's just for Basecamp, it wasn't a problem. The one performance bottleneck we have right now is actually rendering the templates, because we don't cache anywhere right now. And I think that's a testament to how fast it is. We don't really cache anything that we generate. Also because it's pretty inconvenient to cache stuff in Basecamp, because if you saw the dashboard, pretty much every object in the entire system is instantiated to create that dashboard, which is just a single change in one thing would invalidate the cache, and there's just too much work to maintain that cache. So, but it varies. It depends on what you want to do. If you want to build a content management system that 100,000 users have to access, of course you just do some caching and so on. But no, I don't think speed is a problem for Ruby. At least not for web application stuff. There's tons of other areas where it's probably more of a problem. Right. Any?
One more question.
Yeah.
You will release Rails as an open source framework.
Yeah.
Can you say anything about when you will?
Right. Actually, Rails right now is used about, I think there's 10 beta testers using it right now. And actually some are using it to build real systems. But Rails is still complicated enough that I don't want to push some code out that isn't probably documented or doesn't have real tutorials or anything like that. There's too many open source projects that just, oh, look at my amazing code, and there's just a README file saying, play with it. And that just isn't enough for most people. And I found that particularly frustrating. So I'm probably even more adverse to releasing something that doesn't have proper documentation. But Rails is two parts of technology. There's the active record, which is the model part, which is actually can be used separately. If you want to build a GUI application, which is exactly what one of the beta testers is doing, you can use active record for that. And that's going to be the first package we release. Just now got a native Postgres SQL adapter, so it'll launch with MySQL and Postgres, and then a generic database adapter, and we'll probably release it, soon. Right, and then the rest of Rails will, I think, come over the summer. I have another commercial project starting in July that I really want to use a released version on. So soon. Right, any other questions? Otherwise, we'll start coding. Yeah. Okay. The first thing we need is a package of fresh Rails, which is the blank package that contains everything. I just need to make sure that, right, we have a package of fresh Rails here. And what we're going to build is a little weblog system. It's going to have some posts, and then it's going to have some comments, and it's going to be pretty close to the stuff that you've seen in Basecamp. And it's not going to be very pretty, but it's going to show you, we're going to build everything from the ground up. I don't even have HTML templates ready or anything. So to show you how easy you can build something that is well factorated out and uses the entire Rails system and so on. Anyway, let's get started. So we'll start here with a couple of fresh Rails. What I've done before this is I've set up a entry in the Apache config to say that we're going to use this workshop directory, and if we go to workshop, right, we get welcome to Rails, which is, I haven't finished any of the really pretty stuff yet, and you'll see that as we do arrows, that some of it isn't totally pretty yet, and that's also, yeah, part of the reason that I want to clean this up before release. Anyway, now we have a blank system, and we haven't set anything up yet. So the first thing we're going to do is set up I use Xcode, basically just as an editor. The thing about Ruby is that you don't really need an IDE. That's pretty easy to say when there isn't an IDE. So, but anyway, the language doesn't really in the same way require one as do Java. So let's create a new one. Call workshop. Take 5. I practiced a little. Ruby projects. Before we add all the stuff to the project, though, let's set up a few things. Let's say we want a controller, which is going to be the weblog controller, and then we want a post model. As I talked about before, Rails comes with a couple of generators that will just create some simple stub files. Like we have this new controller script, create a controller and view stub files, blah, blah, blah. So if we want run this with weblog, and we're going to need an index file, which is going to list it, then we're going to need to create a new file, and then we're going to need to create an edit one. Great. Right, so now we have these stubs. And then we're also going to create the stub file for the model. You don't have to do this beforehand, but just the way that Xcode works, it's a little bit inconvenient to add files to the project after you started. So it's just easier if you just add the basics you need first. Title equals title. I need to do all of this stuff every time I added another attribute. Which this is just one place I need to do this. I need to do it again in the mapping and all the other places we just talked about. And Rails does all of this automatically for me. Now we have signed the attributes, and now we just need to tell post that it should really save now. When I called save on post this time, you see, remember I called save on post up here as well. Here it created an insert statement where it took all of the attributes that it had and built a SQL for it and inserted that. Down here, it knows that we found an existing record first, and now when we call save this time, it'll use an update SQL statement to update what needs to be updated. Now when we're done, let's go back to the index. Whoop, that's not right. Index page again. Then we remember everything. I think we did. Gonna edit this again. Now really. Now really with body, oh yeah, it's so true. Right. This is interesting enough that we can write and talk a lot here, but I haven't showed any of the other cool features that this has. For example, let's imagine that we now have some time left, or don't we? Or
Actually not, but let us keep on for a few minutes and then
oh, okay. I'll just show one quick thing then, which is let's add some comments to this. So we create a new model called comment. We create a new. I'll do less talking and more typing then. Let's just gonna have a body. Right. Great, we have the comments, and then we describe the relationship. And then we have a page to list these comments. Gonna find the, just gonna find the post. Comments for wonderful things. Right. Take this one out. And instead of cycling over the post, we're going to cycle over the comments. And we're going to pull the comments right out of the association. The reason I can call this .comments now is because I added this association just before. Has many comments, which is a way in Active Record to describe this relationship and give it a bunch of added methods. I could also have, we'll just add that on the index here, for example. I could add how many comments this has. See, comments, and then parentheses, how many. It's gonna have post, comment, count, which is gonna return a number, which is, let's see if we're broken now. I don't think we, oh yeah, we are. 4, right. Whoop, need to include the new comment thing we did here. Oh, right. We didn't give Rails any chance to map how it should find these comments. It should, of course, belong like here. Put that up there. Whoop, and we're back in business. Try counting the number of changes I just did and imagine that in the 5-phase build change loop. And that would be the presentation in Java. So now we have the list of comments, and we're going to add a link to this page. It's going to be comments for, again, a specific post. And we have this comment page for comment in blah, 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 show the comment. Whoop, comment body. And then we're not going to create an interface to do it. Let's just shoot in some comments here. Belong to the last one. Whoa. Gonna talk slang. There we go, and see. Oh, this now has a single comment. Great. I don't think we. Oh. You've gone wrong. God damn it. Oh, that's because we forgot to. That's another sign of not very polished application just yet. But also all of these debugging screens you saw before, that's of course only meant to run in developer mode. That is not something you want when you have a done application. And actually the reason why I can do all these changes so quickly right now and not restart anything, not even Apache, is because all this right now just runs at CGI. Which is horribly slow if you have an application that really uses Access, but it is actually perfect when you just have a single developer developing, because he gets a fresh interpreter every time, and he can test and make changes really fast. Whereas when you run this as a real application with many users, you use something called mod Ruby, which is one that keeps the interpreter around, but which also then needs to be restarted when you make changes. Right. Needed. Oops. Oh. All right. a method post. Oops. This is not a local variable. This is one we assigned, so we need to prefix it like this. Oh yeah, so true, where are our comments? Maybe we didn't add it to number 4? We did? Huh. Let's see. So it is iterating over them, but it's not called body perhaps? It is called body? Huh. I wonder. So it is something wrong with body. I'm at a bit of a loss here. Huh. We should have stopped earlier. Damn it.
The column type was text, whereas the other one was varchar.
That doesn't. I should still be able to. Yeah, it keeps this. What am I doing wrong here? Okay, let's do something slightly hackish. We'll inspect this. Inspect is a wonderful method you can use to get the internals. Body is nil. Got that. I'm stumped. Oh, I actually didn't show another cool thing, which is that Rails has automatic logging. So let's go in here and say tail F application. So we can, which is pretty important when you have straight mappings like this to SQL. You can get here and then you can debug the application running. So you see we just processed the comments method on web control. You see when it happens and so on. And just as importantly, it'll time how long it took, which is pretty good as a poor man's profile when you're just running on a live system and just want to check how things are going. And you see where the time is spent. Oh, it looks like we spend most time in Ruby here. We take this one. Does get the body. What the fuck? Right, and this concludes the presentation as such. What the? Let's see if we name it something else.
Do you want to find out, or should we take a few questions? Then you can.
Right. Let's just take some questions and debug another day.
Any questions?
Yeah.
Do you think a bank would use Ruby for making an enterprise system?
Probably not, and I think that doesn't have anything to do with the technical aspects of neither Rails nor Ruby, but something to do with what is the decision-making process for something like making a new bank application. That's something like we need to know we can sue somebody if this ship goes wrong, and we need to have big mainstream adoption and all sorts of other things that have nothing to do with the technical aspects of this. But then again, Rails is tailored for making applications the way I make applications, which is pretty low criticality applications, something like information systems and things where you don't lose $100 million if you make a bug. I don't necessarily think that Java is inherently more suited for this, but it's just oftentimes doesn't have anything to do with the technology.
But if you look besides the Rails framework, is Ruby as a language mature? For
I certainly think it is. I mean, it isn't a language designed yesterday. It's from '93, and it has a pretty stable release process, and I mean, it's used by tons of companies all around the world. There's a page on the Ruby wiki called Real World Usage, where lists companies like NASA and Hewlett Packard and a lot of big companies. So yeah, I think it's really, and it's the best example I can point at is it's running Basecamp, and it does so excellently. So applications that are like Basecamp in nature, I can vouch for, but no, I don't know how it will handle bank applications. I never coded anything like that, so right. But for applications of this nature, which is actually what I think most web applications is. Most web applications is not about pushing around $100 million or processing 10 million transactions a day. Right.
Peter,
how do you implement permission checking? For example, if one user is only allowed to update some attributes of an object, and how do you protect against URL hacking?
There's a couple of things. I didn't show any of those because that takes a little bit more time to build it like that. Not a lot more time. One of the things you could do in something like this controller is you could implement a filter. So you could have a before filter saying authentication. This filter would then be run before any of these methods can be accessed, and we could just implement this down here as a private method and say user is authenticated. Right, if this returns true, you can access these methods. If it doesn't return true, you'll get thrown out to some screen asking you to log in or saying that you don't have attributes for it. And the other thing you said is, what if I only want somebody to access half of my post object? Is you can either add, there's a method on Active Record that'll restrict blank with access, like this we do attributes where it just access everything, so I could pass in my own variables if I knew that post had something like administrator or something, I would pass in my own value. You can take these attributes out of this mass assign loop, and then you would have to specifically say post.administrator equals true. And of course, when you do that, you do the check. So you only need these protections for stuff like this mass assignment.
What's unit testing?
Right. Rails actually has.
I have to repeat the question.
Yeah. The question go on Rails itself or on the applications built with Rails?
You talked about functional testing and unit testing, and I didn't saw either of those.
Right, of functional and unit testing in a Rails application. I can just show the stop files. Right here we have this test directory, and I have the unit tests. In here there's already one created for me for the post we created, and there will be another one when I say add existing file comment here. And even better than that, Rails already made a build script for you that will run these. So if we go to this and say, you can see test implementation missing and test implementation missing on both of these. So Rails does a lot of stuff to set you up for both unit testing as this is and for functional testing. Functional testing can be done on two levels, either on the controller itself, where you don't test how the HTML actually looks, and you can also test how the view is rendered by actually looking at the HTML.
Thanks.
Yes. Any other questions?
We saw how easy it was to extend standard libraries with your own methods. Is there a standard way of distributing libraries with unit tests so you can make sure that whatever you added didn't break anything?
Most of the libraries, I don't know even most, but a lot of the libraries in Ruby, Rails included, come with a ton of unit tests. But there's actually a new packaging standard coming up in Ruby called Gem, which is a way of distributing libraries. And they can actually be distributed. If you put your unit tests in a certain directory, you can run these unit tests automatically. But yeah, most new, at least new libraries in Ruby are distributed with unit tests. Cool. Any other questions?
Then we will say thank you for coming down to Roskilde University, and we will present you with this.
Oh, thanks. And maybe just a small note, you can read more about this on rubyonrails.org. There's not a whole lot of information right now, but I'll at least put up this presentation, and it's also going to be the website where the release will come when it comes, which is soon. Right.
And if you will want to hear more from David, you will want you will have to go to Chicago on.
Yeah, it's June 27th. I think there's there's a presentation similar to this, less technical, a whole day in Chicago. So
and at a much higher price.
Right.
And now we will invite you. Iterator will invite you on some beer and soda. Just
excellent. Thank you.
Thank you for coming.